What's up, everybody? Welcome to Coding with Chaim. In this video, we're going to take a look at Deno. So Deno is a brand new framework which was just recently released that allows you to write JavaScript or TypeScript on the server. So I figured in this video, we're going to build a REST API using Deno. So basically, we're going to have a MySQL database with a cars table in it, and then we're going to have a basic REST API that's going to allow you to perform all the sort of standard CRUD operations over that cars table. So we'll be able to create a new car, read all the cars, delete a car, and then update a car. So if that sounds like something you'd like to learn about, watch this video. Okay, so as you can see here in code, we basically have an empty folder. There's no real code yet. The only thing that I do have so far is basically this .vscode folder, and then within that I have a file called settings.json. In this settings.json file, I basically am simply saying deno.enable is equal to true. Now, the reason why I'm doing this is because we're actually using a VS Code package called Deno. And what this basically allows it to do is to kind of configure VS Code to work better with Deno out of the box. Because one of the problems, for instance, that VS Code typically has, specifically if you're actually using TypeScript within your Deno applications, is that Deno requires that you actually use a .ts or a .js extension on your imports. So say, for example, you might be importing import foo from ./foo. So typically you would sort of leave the extension off of that import, but Deno requires you to actually write that extension within the import. Now, if you're writing TypeScript, your VS Code might actually scream at you and say, hey, you're including an extension when you don't need to include the extension. But by telling VS Code that this is no standard TypeScript, but rather we're writing Deno, then VS Code will say, oh, I got you. Like, this is okay for Deno code, but not okay for Node code. And that's kind of all that this does. So that little sort of environment introduction out of the way, let's actually take a look at the sort of 3 steps of what we need to do in order to kind of get this application to work. So the first thing we're going to want to do is actually kind of set up our database. And that's going to be as simple as simply going to any one of our favorite MySQL GUIs. We just create a new database. We can call it whatever we want. We can just call it like Deno test or Deno REST API, doesn't matter. And then we're basically going to use a migrations tool to actually allow us to build up the schema of what our table is going to look like. In other words, what the name of the table is and what are the fields within that table. We're going to actually do that all within code. So actually, there's a library that handles just that. So let me show you that. So as you can see here, I'm looking at the basic documentation for a library, a third-party library that exists within the Deno ecosystem, and it's called Nessie. And basically, what it allows you to do is you can pretty much use it as a client. You can run this from within your command line interface, from your terminal. You can run all these different commands. One of the commands that you can actually run is a sort of init command. And what this does is it actually goes and it creates a file called a nessie.config.ts. And then within that, you basically give it your configuration of how to sort of connect to your database, what type of database you're going to be connecting to, and then it allows you to actually start running some commands to actually go ahead and build up your database schema. Let's actually start putting all this to work. Okay, so as you can see here, I'm in my SQL Pro, which is the GUI of choice that I like to use for my MySQL, and you can see that I've got a database selected over here called Deno CRUD, and as of right now, it has absolutely no tables just yet. And we're actually at this point, we're not even going to be bothering to look into the GUI. We're not going to use the GUI. We're going to handle all the actual building up of the database, all using this Nessie tool, all handling it from within our actual code. Let's do that right now. Okay, so the first thing we're going to want to do is kind of grab this command right over here. It basically says deno run -- allow net, allow read, allow write. These are the sort of basic flags we kind of have to pass to this command. And then we're going to go ahead and grab the actual library by giving it the URL of where it resides. And then we're going to go ahead and call the init command. So we take this command, we paste it into our terminal, and then we just go ahead and run enter. Okay, so if you come back into the code now after running that command, you now see that we have these 3 configuration objects inside of a newly generated file called nessie.config.ts. So in this file, we basically have 3 objects. One is called config Postgres, config MySQL, and then config SQLite. So since we're actually going to be using MySQL, we can get rid of these other ones. We don't need this one right now. The same thing is true for this one. We don't need config Postgres anymore. We're just going to be using config MySQL. And now down here, let's actually go ahead and export config MySQL. So basically what we're saying here is like this. We're going to have a migrations folder that's going to get created when we actually run the migrations commands. So basically this is just a tool that's going to allow us to sort of, again, using code, build up the schema of our database to structure the tables and or the sort of fields that each table has. This is known as migrations. So we're actually going to be having a folder that's going to be in the root of our application that's going to be called /migrations, and that's what we're kind of specifying right over here with this line. And then we're going to sort of set up the connection of like which database we're going to be talking to, and like where to actually find our MySQL instance and actually which database we're going to be talking to. So we're going to be on localhost, much the same. Our port is going to be 3306. Our username is going to be root, and then locally my password, it's not a very secure password, but it's just my local database. So we are actually going to go to the password will just be equal to password, just like that. And then finally the database, as we have just seen, we're calling it Deno CRUD. Okay, so now that we actually got that done, now we can kind of go back to the documentation and see which commands we actually have to run to start building up our migrations. Okay, so as you can see here, one of the other commands, besides for the init command that this Nessie library offers, we also have the make command. So basically what make does is it allows you to kind of create a new migrations file. So far, all we've done is basically create the configuration. Now we actually have to generate a file where we're going to sort of write in code the structure of what our table is going to look like within our database. So we can kind of run this command over here. We're going to basically say Deno run with these flags, allow net and allow read, allow write. And then we're once again going to reference the actual library, and now we're going to call its make command. And then we're going to kind of pass it an argument. In this case, we're going to say create users based on the example. In our case, we're actually going to go ahead and say create cars, because again, we're going to be managing a table of cars. So let's go ahead and run this command. Okay, so after running that command, if you come back into your code now, you'll see that you have a new file called migrations. And then within that, you will basically have this file that has sort of like a timestamp and then the name of the actual sort of file that you've given it. So we've said this is going to be called create cars. And then this is basically a timestamp. And then within that, we're basically pulling in schema from the actual Nessie library. This is the actual sort of object that this is exporting. So you'll also notice that in Deno, when you're actually trying to use a third-party library, there's no sort of installation process. We don't have like a yarn add or like an npm install. We basically just reference the URL to where we want to find this library within our code. We then pull in whatever we want to pull in from it. And then when we kind of compile the code, that's when Deno will actually go ahead and download the sort of source code onto your machine so that you can kind of then have access to it. Right? And so now we're basically exporting two functions. We're exporting a function called up, and then we're exporting a function down. Up will basically take whatever we write and kind of put it into the table, and then down will basically take whatever we've kind of done to sort of tear it down. So if, let's say, for instance, you want to kind of build up a new table, like in our example, you want to build up the cars table, we're going to write what the structure of the cars table is inside of the up function, and then if you ever decide you want to kind of get rid of the cars table, you want to pull it back down, you can do that inside of the down function. So let's do that now. Okay, so here's what we've done so far. We basically, in the up function, we're going to say that we're going to create a new table called cars, right? And then sort of as a callback to that function, we get this actual table object that contains a lot of different methods. We're then saying that we're going to have a table.id. So effectively, we're going to have a column called ID that's going to sort of be this sort of auto-incrementing primary ID for each row. We're then saying that we're going to have a new field called make, which is going to be of type string that can hold up to 100 characters. That's allowed to be null. And then we're doing the same thing for model. And then finally for year, we're saying that year is going to be an integer that can also be nullable. Finally, on the down function, we're basically saying that should you ever decide to run the down function within this migration, you can then just simply go ahead and drop the entire cars table and kind of be done with it. So now the next thing we kind of want to do is actually go ahead and run this migration and then see whether or not we actually have a cars table that's been created inside of our MySQL database. Okay, so as you can see here, we have this command called deno run -- allow net allow read, once again referencing the name of the library, and then we call the migrate function. So let's go ahead and grab that command, pop it into our terminal, and go ahead and run this command. Okay, so there you go. Now you can see that it's telling us that the migration has been completed. So now let's go into our actual MySQL GUI and see whether or not we do in fact have a cars table that's been created for us with the structure that we specified in our migration file. Okay, so now you can see we actually come into our MySQL GUI, and as you can see, we have the Deno CRUD database selected, and we have two tables that have been created for us by this Nessie tool, by the migration tool. The one that we wanted is cars, and we also have this Nessie migrations, which Nessie just does itself to kind of keep track of which migrations it's most recently run. Right, but the one that we care about is this cars table, and as you can see, the cars table does in fact have an ID, a make, a model, and a year, exactly as we specified inside of our migration file. So with that out of the way, now we can actually start building up the actual functions to go ahead and manipulate the data within our database. So let's do that now. Okay, so here's what we've just done. We basically created a folder called models, and then within there, we've created a file called config.ts. And all we've basically done so far is we've gone ahead and we've imported the MySQL driver from within the Deno sort of repository of third-party libraries. So this is the exact URL for that particular repository. And then we pull in the actual client constructor, and then we go ahead and build up a new client, right? So we're basically going to say await new client that connect. Let's go ahead and connect to this client, and then you kind of pass it the credentials that it needs to connect. So we're basically telling it the host name, the username, the DB, and the password. And this is not at all that different from the actual configuration that we did within the Nessie config to kind of tell it how to connect to our database. So just like Nessie needs to know how to connect to our database because it wants to run queries against our database to kind of build up our schema, so to here inside of config, we're going to be using this connected client instance that we've now created to actually go ahead and execute queries of actually creating items deleting and updating and all the sort of basic CRUD operations against our database, we have to use this connected client. And so in order for it to actually connect that database, we have to give it the kind of, credentials and the configuration. Now we've actually done that, and now we can actually start working on the actual functions to manipulate that data. Okay, so let me explain what I've done so far. First of all, I'm importing the actual client, the connected client. So in other words, this client here represents the actual connected instance to my MySQL database that I can start to use to go ahead and actually execute queries against my cars table. Now, as you can see on line 1, I'm actually importing a library called dex. So the basic idea is that when I'm actually using my client instance, I can actually run regular SQL, and that I can then go ahead and execute using this MySQL driver. The problem that I really have, though, is that would involve me writing regular SQL right within my code, which I don't prefer to do. A, you have to worry about sort of like escaping the parameters because you don't want to have like, any kind of SQL injections. And B, it just kind of becomes a little cumbersome to like write proper SQL right within your code. So instead, the library dex actually allows me to write JavaScript or TypeScript in a way that then gets translated into SQL. So I can pretty much write all the queries that I want to execute within my client library, but I get to write it in sort of regular TypeScript land. And it then turns all that query into a string that I can then pass with the sort of exact correct syntax that it needs to be off to my actual MySQL driver. So let me just kind of show you that in action. Okay, so let's take a look at what I've just done. So basically, I've created an interface called car. It's going to have an ID that'll be optional, but it can have it. But if you do have an ID, it's going to be of type number. Make, model, and year. Make and model both are strings. Year is a number. And then we have a function called addCar, which will accept an actual car object. And then here you can kind of see the power of dex. So basically, what I'm doing is I'm actually using dex to build up an insert query. So I basically go ahead and say dex.querybuilder.insertCar. Into cars.toString. So right now, all I've really done is I've used sort of very familiar syntax. If I've been writing JavaScript for any amount of time, this is kind of very familiar syntax, and I haven't had to like really worry about the actual exact SQL syntax. But this insert query, when I call toString on it, is perfect syntax exactly for what the MySQL driver actually expects. Now I can actually go ahead and call this client object that I've imported. So remember, this represents my connected client instance. I can then go ahead and call the execute method on it, passing in the insert query, which is now a string that represents perfect SQL syntax. This then returns a promise, which then resolves to the result of what we just created. So now what happens is I want to actually go ahead and return to the caller the exact item that they've just created. So I actually just made an insert into the database, but I kind of want to go ahead and send you back the exact item reading from the database, the one that you just created. So what I'm going to do is I'm going to build up a new query. This one I'm going to call getQuery. Once again, kind of doing the same shtick. I'm going to say, dex.querybuilder.select.fromCars. Go ahead and build up a query where you're going to be selecting from the cars table where the ID is equal to the result.lastInsertedID. So whenever you're using MySQL, and this may be true for other SQL type databases, when you're doing an insert, what you're then going to get back is the actual ID of the last inserted item. And so that is exactly the ID that I want to use to kind of query the item back to send back to the person who just used this function. Then I'm going to go ahead and once again call toString on it, which then allows me to then execute this query by simply saying client.execute getQuery.then result. Result will have in it optionally rows, because since rows is optional, I kind of have to do this turn array. In other words, if rows does in fact exist, then go ahead and give me the first item results of 0. So you have the very first item, the one that kind of matches. It's going to be an array of just one item, but still, since it's an array, I have to do result.rows of 0. And then if it doesn't exist, I'm just going to go ahead and do an empty string. But if the actual insertion worked correctly, the item will of course always be there. That's actually the syntax that we're using to actually go ahead and actually create a car. Okay, so that actually handles adding a car. Now let's go ahead and write a function that's going to go ahead and get all the cars. Okay, so very simply what we've just done is we've created a function called getAllCars. Once again, builds up a simple get query, just basically saying give me star from cars, turn that into a string. Then we're going to go ahead and execute that and then return the resulting promise from client.execute. So now that leaves us with edit car and then delete car. So I'm going to go ahead and fill those in now, and then we'll kind of go over the code. Okay, so what we've just done is we basically created the last two functions. One of them here is called edit car, which will basically take in an ID, which is a type number, a car that's going to be the kind of new car that you want to actually edit right now. And so then what we're doing is we're creating an edit query by simply saying that we're going to go to the cars table. We're going to update the car where the ID is equal to the ID that we're passing in. And we're going to turn that into a string. We then execute that query, passing in the edit query. And then once again, we kind of want to get the newly generated item, right? So what we're going to do is in other words, the item that you just sort of edited, I kind of want to send you back the new version of it, the sort of updated version of it. So what I'll do is I'm going to go ahead and make another get query by kind of going into the cars table, getting you the item where the ID is the one that you've just edited. So in other words, where ID is equal to the ID that you just passed in. And then finally execute that query by passing in the get query, and then once again giving you the result of 0. Finally, we come to the delete car. All we do is pass in an argument of type of ID that's of type number. Building up the delete query where we go to the to the cars table, we call the delete method where the ID is equal to the ID that you just passed in, turn it into a string, and then we actually go ahead and execute the delete query. In this case, we just return the promise, but we don't really care so much about the result. We just kind of want to know that it's in fact been deleted. So that basically does it for the actual functions involving the talking to the database directly and kind of manipulating the data. Now we can actually start working on the actual server. Okay, so what we've just done so far is we've created a new file called server.ts, and they're importing a library called denotrain. So denotrain is the one sort of that from my research so far, that seems quite similar to Express within Node. So if you're already kind of familiar with Express within Node, then denotrain might be a good fit for you, but there are some other sort of server frameworks that exist within Deno that you may want to check out. For me, denotrain kind of caught my eye. So what we're basically doing is we're importing this application constructor. We're creating a new app instance by calling the application constructor, passing in the port. So we're going to say that we're going to kind of listen on port 1337. And then finally, all we're doing is we're going to say app.run. Okay, so now let's actually go ahead and create the API. Okay, so what we've just done so far is we've gone back to the same denotrain library, and we've imported the router class now. And then we've gone to our models cars file, the one that we just kind of created, with all this sort of functions that interact with the actual database, and we've imported all the functions from within that file. So now we go on line 4, we create this router. We're going to just simply call it API, and then we can kind of start setting up our endpoints. So you notice that a lot of this kind of seems very similar to Express, but there are, I think, two key differences that jump out at me right when I first looked at this code, and it took me a minute to kind of get used to, but it's actually not that bad. So the first thing that you notice is that with an Express, we typically have like a rec, res, and then optionally a next. Here, all you get is a sort of context object. So everything that pertains to the actual request, incoming request, as well as the outgoing response, and all the headers and all the cookies and all that shenanigans, all that lives within this one context object. The other thing that kind of stands out is within denotrain, whenever you're just simply trying to return basic JSON, you can really just go ahead and just do return result.rows. So here we're basically returning a promise that kind of just resolves result.rows, and then denotrain is kind of satisfied with that, and it just takes whatever resolves within the promise and then just kind of sends it back. And by default, this will just go ahead and send back a status code of 200 and then the actual kind of result. And so typically within Express, you'd actually do something more like the lines of like res.status200.json, and then kind of build up your sort of response that way. But Deno is kind of satisfied to just go ahead and say return, which actually is kind of nice once you actually start using it. That's the basic GET request to kind of get all the cars. Now let's go ahead and build up the actual POST request to kind of create a new car. Okay, so what we've just done is we basically created a post route that's once again going to go to just simply slash, and then we're building up this body object. So we're going to sort of make a body object that's going to have the make, the model, and the year, which is basically going to be what the add car function expects. It expects you to pass in something that has this exact shape. And then we're basically saying that the make you'll pull out from the context.rect.body. So in other words, instead of simply doing rect.body, you now have to do context.rect.body, because remember, everything that pertains to the sort of request and response all lives inside of this context object. So we see context.request.body.make, same thing for model, same thing for year, and then we very simply call our add car function, passing in this body, we then get the new car. And then here's one thing that we kind of have to do a little different, is instead of saying res.status and then kind of creating the status that we want to kind of send back, we go ahead and say context.res.setStatus, and then we kind of pass in the number of the status code that we want to set. So since we're creating a new entity, I think that the correct status code for such a thing is to have a status code of 201. So that's why I'm saying context.res.setStatus is equal to 201, and then I go and actually return the new car. That basically takes care of the getting all the cars and the creating a new car. That leaves us with actually editing and deleting a car. So let's go and work on those now. Okay, so let's take a look at what we've just done. Basically, I have created a patch route that goes to /:id. I build up the car object once again by pulling it out of the rec.body that lives on my context. Then call the edit car function, passing in the context.rec.params.id, casting it as a number. I'm basically saying it's going to be a number. So since the edit car function expects the ID to be of type number, and since params.id is not necessarily going to be a number, it could technically be a string also, we're basically telling TypeScript, like, don't worry, you can trust me, I know that this is coming in as a number. So we're basically casting it as a number, and then we actually go ahead and pass in the car object that we've kind of just sort of built up, pulling it out of the body. We then get the result, and then we simply go ahead and return the result. Very, very straightforward. This will just send back a status code of 200 and the newly updated item that we've kind of just edited, right? This then brings us to our delete endpoint. So we're basically going to say that we're going to go to /:id. We're going to call our delete car function, passing in the params.id, once again casting it as a number for the same reason as we did with the edit car. Delete car expects it to be a number, so we have to force it and tell TypeScript that we know that this is a number. And then we simply call the .then, setting the status code to 204. Since we're not actually going to be sending back any content, we're just going to kind of send back a 204, indicating that it was a success. But since there's no content, we're saying 204. And then we just go ahead and say return true, because in order for us to sort of signal to denotrain that there's nothing after this, you can kind of close off the connection, we basically say return true to know that there's nothing left to kind of wait for it. And that pretty much is our REST API. Now let's actually go ahead back to the server and kind of tell denotrain that if somebody actually goes to /API/cars, this is the actual router that they should be using. So let's actually configure that now. Okay, so what we've just done is we've imported the API from ./API/cars, the one that we've kind of just created. And then here, anyone who's basically ever used Express, this looks pretty familiar to you. We're basically saying that whenever you're going to get any kind of request that's going to /API/cars, I want you to go ahead and use this router that we've kind of just created over here. So therefore, this can just be all /. I don't have to actually specify the exact endpoint, because I've already said here that if you go to /API/cars, use this router. Well, that pretty much does it for all the code. Now it's the question of actually seeing if we can get the app to run and actually testing it all in Postman. Okay, so as you can see, we're basically trying to run the application by saying Deno run server.ts. So we're effectively calling upon the Deno runtime to go ahead and execute our server.ts file. But as you can see, we're actually getting an error. It basically says that it won't allow us to run because we have a permission denied. So this is actually one of the features that Deno has sort of by default, and this is they call secure by default. That means that you can't really make any sort of network access, or you can't write or read to files without actually giving an explicit permission. So in order for us to actually, and since we're trying to actually use a web server and actually create an actual internet connection here, we have to actually give it the allow net flag. So we have to rerun this command by giving it the allow net flag. So we'll do that now. So we're basically saying Deno run allow net server.ts. Let's try to run that now. And as you can see, now it's actually serving on localhost 1337. So we're going to go ahead and open up Postman and start seeing if we can kind of run through our API to see if each one of these endpoints actually work. Okay, so as you can see here, I'm basically creating a post request that's going to go to localhost 1337 /API/cars. I'm filling in the body as form URL encoded. I'm saying that we're going to have a make, which is of type Ford, a model of type Mustang, and then a year that's going to be 2010. Let's actually go ahead and execute this query and see if it works. Okay, so now as you can see, we now have a response. We're getting a 201 created, and we're actually seeing that we now have an ID of 1, make a Ford, model is Mustang, and then the year 2010. So far, the actual creation has actually worked. Now let's go ahead and simply create one more. So we're just going to go ahead and change this to be a GT, just a Ford GT. Hit send. And now we have 2 items created, which will now allow us to actually go ahead and do a read all to kind of see whether we actually get back an array of all the items that we've actually just created. So let's do that now. Okay, so as you can see, I now have a GET request open to localhost 1337, going to /API/cars. If I execute that, I now get an array of 2 cars. One is a Ford Mustang, one is a Ford GT. Now that leaves us with actually testing the actual edit as well as a delete. So let's do the edit first. Okay, so as you can see, I'm now trying to go to localhost 1337 /API/cars/1. So basically going to try to perform a patch request on the car that has an ID of 1. The model is going to be a Mustang GT as opposed to just Mustang. So let's go ahead and run that and see if we actually get the updated entry. And sure enough, as you can now see, we get the response back. We get a 200 OK, and we're actually getting now the model is no longer simply Mustang, it's now a Mustang GT. Now let's actually go ahead and delete this item from the database. Okay, so as you can now see, I now have chosen delete method. I'm going to localhost 1337/API/car/ID of 1. I go ahead and run the command, and we get a 204 no content. It's been successful. And if I come back to the get for all the cars and run this command again, I now only get the Ford GT. I no longer get the Ford Mustang because I've effectively deleted it from my database. Well, that does it for this video. I hope you enjoyed it. I hope you found it useful. If you did, please drop a like, subscribe, and I'll see you in the next video.